This is Carsten from the Modularity team, and in this demo I'm showing you the DHCP client container. The sources are as usually available on GitHub, along with some documentation, and now I'm showing you the Modularity file. It currently requires Bootstrap instead of base runtime, but that's going to be fixed very soon. Down there are the dependencies that are being built along with the module. I'm checking the Modularity file for any errors or warnings. There are warnings, so I have a look at the log file, search for the warnings. Okay, something about not being implemented. Next one is about spelling problems, because he doesn't know the words at all. Another spelling problem. Okay, that he can't know about. So nothing serious here. Now I'm building the module. I'm speeding this one up about 20 times, so it doesn't take that long. It should be around 16 to 20 minutes. That's getting really fast now. So it's building several packages in mock, all the dependencies that are listed in the Modularity file. And now it's building DHCP. That's it, it's already done. All the dependencies are built. They have been saved in the results directory. I moved the latest one to my DHCP directory. There are some permission problems that I'm going to fix. Okay, here are all the files that have been created during the module build process. I create a repository out of them and upload them to my web space on fedorapeople.org. Takes a couple of seconds. Done. Let's have a look at the DHCP client Git repository. That's the URL where you can check it out. And in the Docker file, there are some labels that are required by Dockerfile lint and all our container acceptance criteria. I'm checking that with Dockerfile lint, so there's just one warning about not having an expose instruction. That's okay, because that daemon process doesn't use any parts. This is the DHCP module repo that I just created and uploaded to my Fedora people web space. And there is a file run dhcp.sh, which just parses the interface variable. There's no default set for interface, so that it probes all interfaces at the moment, but you can list the interfaces that should be configured by DHCP client with the interface variable on the Docker command line. Now let's try some commands in the container. Let's run it with interface enp nil s25 ifconfig is not available in the container, but the IP command is. Let's have a look at the address. Oh, the host interfaces are not available. Let's add net equals host. Repeat the IP address command, and there are the host network interfaces. We are concentrating on the npno S25 because that's the wired interface. There's no IP address assigned to it. Let's try to set an IP address. IP address replace is exactly what DH client does internally, and the operation is not permitted, even though I'm the super user. Let's set the capability netadmin. Oh, typo, sorry. Check the IP address, and it seems to have worked. So for our test, I have to delete the IP addresses after each run. Let's have a look what the container does per default when you run it. So the command line is user sbin run DHCP. Let's run it without bash. And you see failed to create bus connection. That's caused by the dbus not running. But the interface has been configured. As the next task, I try to get rid of the root user ID in the Docker file by setting user daemon. I rebuild the container. There you can see user daemon. I run it again, this time with bash, so I can be interactive. My ID is daemon. I try to set the IP. And even though I have set the capabilities, I can't set the IP address as user daemon. Next, I try to run it as a privileged container, just by adding -- privileged. My ID is still daemon. I try to set the IP address, and it's still not permitted. I change the user ID back to 0 as root. Rebuild the container, that's fairly fast. I run the container, and user ID is a root. And I already know that this command works now. There you can see it. I remove the IP address for more tests. I've created a service file for systemd so that the container can be run as a standalone container. These are the contents. It's fairly easy, it just runs a Docker. I'll start it with system control start service file. I check the address, and there it is. I stop the systemd service, delete the address again, it's gone, and now on final check that the normal container is still working. Looks like it, and that's it. Thanks for watching, and don't forget to subscribe. Bye.